All right, this is the Math 99 final exam review. We're on number 6. We're writing mathematical expressions for word phrases. So the first one says the quotient of a number and 3 more than the number. So quotient means divide, only we won't be using the old-fashioned division sign. We'll be using a fraction bar. A number, we're going to use x. 3 more than the number. In this case, it doesn't say times more, so it's addition. So we know there's going to be a fraction bar involved. So we have to decide what's going to go on top of the fraction bar and what's going to go on the bottom. So the quotient of a number and 3 more than the number. So the number is going to go on top. The and is where we're going to put the quotient bar. So a number and, meaning divided by, 3 more than the number. So 3 plus, oh, and by the way, the number is x. So on the bottom we need 3 plus x. The quotient of a number, mystery number x, and 3 more than a number. Let's take a look at the next one. The product of 5 and 2 more than a number. So we know the multiplication is going to take place here. Product is multiplication. So 5 is going to get multiplied by this, 2 more than a number. Again, more than, since it doesn't say times more than, it's just plus, and a number is x. We are going to be multiplying 5 by this. That means we're going to need parentheses around this amount because there's more than one thing happening here. So it's going to be 2 more than a number, so 2 plus our mystery number, and product means that 5 is going to get multiplied by that. Remember, there's an invisible times sign between the 5 and the parentheses, which will make the 5 get multiplied by both things inside. Take a second to think about that. We're going to move on to the last one. The product of 10 more than a number and 4. This one is actually very similar to the last one. Product means times again. The product of 10 more than a number and 4. So we're going to be putting the multiplication sign right here where the and is. That's where the multiplying is going to happen. So the product of 10 more than a number. How do we write 10 more than a number? 10 plus the number. A number is x, more than is adding. So that amount together is getting multiplied by the 4. The and is where the multiplication is taking place. So I got to put parentheses around that. And then we would go times 4 on the end or put the 4 out front, which is what we usually do, just like in the last one, so that the 4 gets multiplied by 10 more than a number. Let's squeeze in one more problem. What is the solution set of this linear equation? All right, let's start by drawing our wavy line down the equal sign. When it asks for the solution set, it means solve for the variable. In this case, we're going to try to get x alone on one side of the equation. Remember your step 1 is to simplify both sides of the equation. So let's look at the left side first. Is it as simple as possible? Well, no, it isn't, because we've got parentheses. So that means we're going to want to distribute the 5 outside by multiplying it by both things inside. So that's going to give us 5x, 5 times x, minus sign in between, 5 times 1 is 5. Now bring down anything else you haven't done anything with yet. Write your equal sign on the wall. Now let's go over to the other side. And on the other side, we also have parentheses that we better take care of by, again, distributing or multiplying that 3 by both things inside. Now write down everything from left to right as you simplify. I haven't done anything with the 2x yet. Plus, now we're going to go 3 times x, which is 3x. The minus sign in between, and then the 3 times the 1 is 3. Now let's take a look at each side. Are they as simple as possible? Well, no, because I've got some like terms I can combine on this side. I can put together the minus 5 and the plus 3, because they're plain numbers. They are like terms. They can be added to each other. So again, write down the 5x, and negative 5 plus 3 is negative 2. So I'll write minus 2. Put your equal sign on the wall. Let's go over to the other side. Do we have any like terms? Well, yes, we do. We've got a 2x and a plus 3x that can be put together to make 5x, and then bring down the minus 3. So now we have a new equation. 5x minus 2 equals 5x minus 3. At this point, you should realize that these two sides look almost exactly alike, except on this one we're taking 2 away from this amount, 5x, and here we're taking 3 away from 5x. Now how could these two sides ever be equal if you're starting with the same amount, here and here, but here you're taking away 2 and here you're taking away more? This should make you realize something's wrong here. If I continue to try to solve, for instance, if I try to do plus 3 on both sides, I get 5x plus 1 equals 5x. 3's are gone. If I kept going and did minus 5x on both sides, because I want to get x alone, and the only thing I can do is go to the busy side and take away a 5x, I get 1 equals 0. I get a contradiction. I get something that doesn't make sense. This is called a contradiction, and there is no solution. No solution, because we have something that doesn't make sense. All right, we'll go on to the next video and begin the next problems.